This project will cover an upgrade to a wallboard handling and packaging line. So what is wallboard? It's a gypsum rock core between two thick pieces of paper that can have various qualities depending on the product, from water resistance, mold resistance, fire retardant, and significant strength properties. It makes up interior walls and ceilings and fastened to metal or wood studs like you see in the left picture. This project focuses on the handling and packaging side of the manufacturing process. So the board is already made, and in this installation, it is cut and then labeled, which you see in the right picture. We have two boards that are labeled together, and then in the middle picture, it is stacked accordingly into specific sizes. And what separates those boxes or units are what we call sluters, and that allows forklifts to access each individual unit to safely move it on and off of trucks, around a warehouse, onto job sites, and rail cars. A key component of the proposed project will allow 4 boards to be handled instead of only 2, like the right picture, which makes for currently a very fast and precise cycle time and excess wear and tear on the equipment, as well as increased risk of jams. The project is for USG, which is my employer. USG is a privately owned building materials corporation headquartered in Chicago with 45 locations in Mexico, Canada, and stateside. This site in Aliquippa was built in 2000 as a greenfield site from an old steel mill. We currently operate 6 days a week, and to put in perspective how important the technology, automation, and labor issues that we will talk about is we make about 500,000 sheets a week. So a 4 by 8 foot sheet that you can easily find in any Menards, Home Depot, or Lowe's. Making about 500,000 and moving those every single week can be very labor intensive and also very fast paced. While the existing equipment is only 22 years old and could likely last another 15 years, but not at the same efficiency or reliability, there are many technology and equipment improvements over the past decade. Along with labor shortages in manufacturing industry, increased labor wages, and available capital funding, make this a very justified opportunity. We have been kicking this project around for about 2 years and really jumped into the scoping and preliminary bidding in the last 6 months of 2021. It is expected to be presented to the board of directors next month. This project is very unique in that it is a complete overhaul with many multifunctional components, not just individual upgrades, additions, or replacements. It will be replacing a 3-leg 8-stacker unit with a 3-leg 3-stacking unit. It will address technology and automation concerns, including outdated controls and the network infrastructure. And it will address labor challenges from a lack of interest in shift work and manufacturing positions, as it will reduce the amount of operators on each shift by 2 for a total of 6 operators. The budget is $23.9 million, and there are a lot of internal resources for programming and electrical and external for equipment and installation. To best understand the project, I constructed 2 elementary aerial views of the equipment layout. The yellow crosses represent required staffing. The top diagram represents our existing layout, which requires 6 operators and is very expansive, covering 700 to 800 feet wide. The bottom layout is what is proposed. It only requires 4 operators. It's much more concise. While visually it may look like we're losing a lot of space and area to work the board, given the equipment that we are proposing to install, it actually gives us a lot more vertical space and operator-friendly areas to access and work around. I can't use actual prints or go into further detail on some of the handling automation technology due to proprietary and competitive reasons, but this does give a basic representation of the differences. I did purposely align them on the left side so you can visualize the actual footprint and how much more condensed it is. Success criteria will largely rely on the equipment being able to operate with a 98% uptime, and any delay, whether it's mechanical, electrical, programming, or operator induced, results in about less than 2% of its total time. There will be quality specifications such as the correct length that is cut, how the labels are placed, and the quality of the stacking. We must meet the 4 on-time outages, which, flipping back to the diagram, each outage will cover one leg, and then the last outage will cover the saw. So it'll be leg 3, leg 2, leg 1, and then the saws. There will be some coordination where we can run some of the old equipment and new equipment at the same time to maintain some capacity. And then commissioning and integration will be absolutely critical, as that will set the stage for how we continue to operate for years. This is a 28-month project, so I pared down the timeline to quarters for ease of interpretation, with the biggest activities highlighted here. This does rely on the board approval, which only occurs 4 times a year. Once we submit for approval, we will get drawings approved with the vendors and give them a PO. That PO will secure us a production date. Now, lead time of the equipment is 18 to 20 months at the current rate. And if the vendor has delays with project and the lineup before us and other customers, that could potentially snowball and push our dates out further. Before the equipment's delivered, we will go on site to the vendor and do an FAT, which is a factory acceptance test. And that's where we look at all of the equipment, we watch it operate individually and make sure it meets our expectations. After the outages, there will be commissioning and training, and that will put us about 28 months from submitting for approval. Quality and plan includes a lot of external specifications that we have to abide by in manufacturing, as well as the gypsum in the product that we make. The NFPA 70E are electrical guidelines that cover arc flash and energy isolation requirements and more. ASTM covers structural and UL covers fire rated. There are USG safety programs that cover guarding, safety interlocks, and operator accessibility. And then the Gypsum Association specifications do cover some handling and stacking requirements. This product and those units aboard that you saw in the earlier pictures have to be able to withstand transit on rail and flatbeds as far as Miami, or even shipping containers to the Caribbean. In addition to those external specifications, there are internal, mainly being the operations, how the interfaces of the computers work and the operators are easy to use, the alarms that we have, maintenance and upkeep of the equipment, smooth efficiency to maintain that reduced labor, maintaining our speed so we're not having to slow down to keep our quality and our safety in line, and the IT connectivity as more technology goes wireless. Here's the work breakdown structure, which is a lot to digest, but to sum it up, there's 43 tasks with 28 persons and 4 main categories we could split this into. The first category holds a lot of the vendor-related activities, such as scope, bids, install, almost all of the mechanical components and commissioning. The second category is plant-related activities, such as spare parts, maintenance tasks, testing, and training. The third is corporate sourcing to ensure smooth serviceability to customers. Fourth is programming and electrical components. The responsibility assignment matrix is even busier, so I did not include that, but all tasks do have a secondary, which was part of the risk planning, and a large majority of the tasks have multiple support persons to provide input and communication. The deliverables overall range from single-day walkarounds that may take a couple hours and purchasing, which is a one-time event, to the round-the-clock installations and outages, and then a lot of downtime while the lead time of the equipment takes so long before it is delivered. The total resource usage list was 3 pages. So I'm using this resource overview graph from Microsoft Project to give a high-level overview of the allocation. There are a lot of hours for many different skill sets. My role in this project as the operations manager of the production line varies from oversight, approving drawings, soliciting feedback, checking in, analysis, and a lot of communication. There is a spike on the hours for contractors as they will be handling the installation, and Furman, who will be writing the code for all of the programming. The Gantt chart shows the full schedule spanning the 28 months and the list of 43 tasks. There are quarters and months on the x-axis at the top, and you can see a handful of activities at the beginning and a flurry of work packages being completed in the last 25% of the timeline. That is when the install, outages, commissioning, training, testing, quality control, documentation, and stocking parts all occur. Here is our total budget. So for our budget for this project, we knew we had to come in under 25 million. So our estimated total is 23.9 million. The material cost, which holds the bulk of it, includes all of the labor also associated with that material cost, such as installing the equipment or running the electrical wires and installing the panels. The labor costs at about $500,000 represent pure labor tasks such as training, writing the programming, electrical drawings, and the such. While contingency is typically a percentage or always a percentage of the total cost, in this scenario, I took it from the $25 million budget, as there will be a secondary project proposal that covers all of the additional waste and delay occurred with the commissioning and in the first 6 months of operation. This is a very standard process within our organization. The secondary file will account to just about 1 million from our preliminary numbers, and the accounting of it is handled as an expense item versus this project, which is depreciated capital. As you can see on the graph on the right, the bulk of the spending comes in once the equipment is delivered at the beginning of the very last year, and the very final payments are made on all of that, and we have a lot of labor on site for the commissioning and training. The risk register covers items from technological to human, usability, project team, organizational, and strategic. There's 3 that I will focus on, and the immediate main concern is using internal programmers and external equipment vendors, which is a first for a company on a project of this scale. We will not be able to handshake the 2 components until installation, and instead of necessarily a response plan, we are instituting a proactive plan, which is keeping the programmers on site for almost 2 months straight to quickly respond and identify any glitches in the programming and maintaining our efficiencies as much as possible. The green box shows the one risk that rates high in both occurrence and impact, which is glitches and issues that the operators, maintenance, and programmers will have to work through after installation as they learn the new equipment. This can add up to extensive delay and waste product, which is why we'd have the second file after this, and quickly affects our customers as we have very little downtime during the week to make up for it, and our warehouse turns over every couple of days. We are planning for several return visits from both the vendor and programmers to achieve optimal operations as soon as possible. Installation work is the blue box, which really focuses on the outage periods. While we have these specific periods, other plants are adjusting their operations to manage any product that we cannot meet our customer demands. And our customers also expect us to return to normal after those outages. Delay will be very detrimental if we do not get our uptime back on schedule for the outages very quickly, as no product is being made during those times versus any sort of reduced capacity. The response plan for that we're leaving Sundays open, so those are extra hours that we could utilize to make up for some lost time, as well as working 12 hours on Saturday instead of 8. And all of the outages will be 24 hours around the clock to take advantage of all time available and reduce those outage periods. So in conclusion, we are spending about $24 million, and 2.5 years later, the manufacturing line will have a reliable, less labor intensive, and higher performing operating line. This line is critical to the network as it typically ranks in the top 3 of all metrics in our North American facilities, from recovery, delay, and efficiency, as well as safety and quality. It is a prominent employer in the area. It will not add any increase to the operating cost from a power perspective. And since it can handle 4 boards in one stack versus just